Hello everyone, welcome to Garan Tulpul and this is Yogesh Garg. So in this video we are going to discuss JEE Advanced 2013 Paper 1 question number 41. So what we have, that complex numbers alpha and 1 by alpha conjugate, they lie on circles x minus x naught square. So this is the first equation of first circle and it is satisfied by alpha, and this is the equation of second circle, it is satisfied by 1 by alpha conjugate. Now z naught is equal to x naught plus iota y naught, right? It has been given and it satisfies this equation. So this is also true. 2 mod z naught square is equal to r square plus 2, then alpha conjugate, then alpha mod is. Now there are certain interesting thing over here, and there is certain very important knowledge which has to be applied over here. That is how to write this equation, in terms of complex number. That is how to write this in terms of complex number, right? Modulus, in term of modulus. Or what is the equation of circle in terms of complex number? It is z minus z naught conjugate, z naught, right, where z naught is the center, x naught plus iota y naught, mod is equal to r is the radius over here, right? Or we can also write this as z minus z naught mod square is equal to r square. Why I'm doing square over here? Because then only we are able to evaluate this. Also it must be known that this z is satisfied by alpha, so put alpha over here. Alpha minus z naught modulus square is equal to r square. Fine. Now use the idea that the modulus square, it means that you have this complex number alpha minus z naught, you have to multiply with this alpha conjugate minus z naught conjugate, right? It is equal to r square. Now evaluate this. Alpha into alpha conjugate is modulus alpha square minus z naught into alpha conjugate, alpha into minus z naught conjugate, so minus z naught conjugate alpha minus z naught into minus z naught conjugate, it is plus z naught into z naught conjugate is mod z naught square is equal to r square. So we have this expression, right? First is this, what we have this expression, right? Also what we can do, we can simplify this and convert this in terms of r square by using this idea, 2 z naught square is equal to r square plus 2. So it means from this what we can do, we can say z naught mod square is equal to r square by 2 plus 1. Use this, right? Apply this over here. Mod alpha square, take minus common, z naught alpha conjugate plus z naught conjugate alpha, and this is plus z naught square, which is r square by 2 plus 1 is equal to r square. This I have done just to simplify this, right? So first we have this thing, we'll move on further, right? This is first equation, we'll simplify it later on. We have one more thing, we have one more equation, 1 by alpha conjugate, it satisfies second equation, which is z minus z naught mod is equal to 2r, not r, because here radius is 4r square, or we can whole square it as well. Second equation can be written as z minus z naught mod square is equal to 4r square. Now replace z by 1 by alpha conjugate. So we have 1 by alpha conjugate minus z naught mod square is equal to 4r square, and this can be written as 1 by alpha conjugate minus z naught into whole conjugate of this, which is 1 by alpha minus z naught conjugate. It is equal to 4r square, right? Now what we can do, just multiply this 1 by alpha conjugate into 1 by alpha. It is 1 by alpha into alpha conjugate, which is 1 by mod alpha square, right? I think I have written this directly over here. So we can write it directly over here. It is 1 by mod alpha square, alpha into alpha conjugate, minus z naught by alpha, 1 by alpha conjugate into minus z naught conjugate, it is minus z naught conjugate by alpha conjugate, fine, plus z naught conjugate, why I am writing plus, minus they get plus, z naught into z naught conjugate is mod z naught square, it is equal to 4r square. Also we will replace mod z naught square by r square plus r square by 2 plus 1, right? We will do that. So again what we can do, how can write this expression, 1 by mod alpha square, take minus common and also take LCM. So minus z naught alpha conjugate plus z naught conjugate alpha upon alpha into alpha conjugate mod alpha square plus z naught square is r square by 2 plus 1 is equal to 4r square, right? So also let us simplify it a little bit more. Multiply this with mod alpha square. So multiply this with mod alpha square. So this will be 1 minus z naught alpha conjugate plus z naught conjugate alpha plus mod alpha square into r square by 2 plus 1 is equal to mod alpha square into 4r square. So 4 over here and r square over here. Now what we should do actually, this is second equation. There was first equation, this is second equation. I think it must be hidden, right, due to video. Now it should be visible. Now we have first equation and second equation. Think for a while, what should we do? What is something which we don't need? We have to express mod alpha square. We have to find mod alpha, right? We have to find mod alpha. So we have to eliminate. What we have to do? We have to eliminate this, at least this much expression. This has to be eliminated anyhow, right? For r, we can think for it later. You must be confused, getting confused that what to do with r square. It is going to be eliminated, right? We don't know, but what we know for sure is this is a useless expression. We should eliminate this. So directly subtract first and second. Just subtract first and second, right? This is first and this is second. Subtract. So I am bringing this first equation in denominator downwards. So this is first equation. Let us take it down. Just subtract first and second, right? 1 minus 2. So mod alpha square minus 1. Okay. This get eliminated. This minus expression. This minus expression. R square by plus r square by 2 plus 1. And this is mod alpha square r square plus 1 by r square by 2 plus 1. Take r square by 2 plus 1 common, and this is 1 minus mod alpha square, right? And on the other side you have r square minus 4 mod alpha square r square. So take r square common, 1 minus 4 mod alpha square. So this is what we have. Now how to proceed? See what we can do. We can clearly see we can take this common, 1 minus mod alpha square. This we can take common. So we should take this common. 1 minus mod alpha square, let us take this common. So we have r square by 2 plus 1, and this is minus 1 is equal to r square into 1 minus 4 mod alpha square. This is plus 1 minus 1 get eliminated. R square get eliminated. It cannot be equal to 0. This is 2. Multiply to 2 over here. So finally what we have, 1 minus mod alpha square is equal to 2 minus 8 mod alpha square. Now just solve this to get, this is minus 8 alpha mod alpha square, shift it on the left side, you will get 7 mod alpha square, shift this one on the right side, you will get 1, and from this you have mod alpha square is equal to 1 by 7 clearly, which implies mod alpha is equal to 1 by root 7. That is your answer. So this question, yes, it involves the concept of writing the equation of circle in terms of complex number, and also it involves the idea that you should replace mod z naught square and you have to eliminate this particular expression, z naught alpha conjugate plus mod z naught into alpha conjugate plus z naught conjugate into alpha. We should eliminate this. So these two things will determine this question, right? And yes, this was a good question, but I would not say that it is very difficult. It is a good question, no doubt, right? And again, what is the perspective of discussing this question at this particular moment of time when you have JEE means in less than 1 minute, or less than 1 month, right? See, I say this with surety, this sort of question can appear in mains examination. The level of mains, as per the level of maths in mains examination, it is increasing year by year. This sort of question can be expected, right? So stay tuned, keep watching our Gurukul. In case you have any doubt in this question, please comment, and also if you like the content, share it with your friends, subscribe the channel. We'll meet in more such videos.